In this video, I'm going to go over the solutions to 2024 SQA Higher Maths Exam Paper 1. Question 1. Here's a diagram of a straight line. It passes through the point 0,4 and makes an angle of 30 degrees with the positive direction of the x-axis. We want to determine the equation of the line. The first thing you've got to know is that the gradient of a line is tan theta, where theta is the angle that the line makes with the positive direction of the x-axis. Now we know what that is, it's 30 degrees, so we can say the gradient of this line is tan 30. Now we don't have a calculator, we've got to get an exact value for tan 30, so we've got to remember this triangle here for exact values. There's 30 degrees, tan is opposite 1 over adjacent, root 3. So the answer for that is going to be tan of 30 is 1 over root 3. All we need now is the y-intercept. Well, there's the y-intercept there. We can see that it's 4 up. So the answer is c equals 4. So the equation of a line is given by y equals mx plus c. M is here and c is there. Put them in and we get y equals 1 over root 3 times x plus 4, and that's worth 3 marks. Okay, question 2. A sequence is defined by the recurrence relation un plus 1 is 1/5 of un plus 12 with u1 equal to 20. We want in part A to calculate the value of u2. So u2 will be 1/5 of u1 plus 12. We know what u1 is, it's 20, so we say 1/5 of 20, which is 4. 4 and 12 is 16, so the answer is u2 is 16, and that's 1 mark. Part B, part 1 says, explain why the sequence approaches a limit as n tends towards infinity. For this recurrence relation, we know that A is 1/5. Now that's the multiplier here, 1/5. And then B is 12. That's the number we add on after we multiply the previous term by 1/5. So what do we know about this? We know that this will approach a limit if the multiplier, that is 1 over 1/5, is between -1 and 1. So as that's true, the sequence approaches a limit, and that's worth 1 mark. We want to calculate this limit. Now there's a nice formula for this limit, and it's this. The limit is b over 1 minus a. Here are the values for a and b, so we can say 12 over 1 take away 1/5. Now there are a number of ways you can do this. The quickest way that I like to do it is multiply, because we've got a fraction of 1/5, I'm going to multiply this by 5 and everything here by 5. So we get 5 12s are 60, 5 1s are 5, take away 5 times 1/5 is 1. That's 4, and 60 divided by 4 gives you an answer of 15. And that's the answer, worth 2 marks. Question 3. We're given y equals a bracket to the power 7. We want to find dy by dx. So we differentiate, so there's y. We differentiate by bringing the 7 to the front. The bracket power becomes 1 less, so we have 7 take away 1 gives you 6, and then we multiply by the derivative of the bracket. The derivative of 5x squared is 10x, and then when you've got a constant, the derivative is 0, so it's just going to be 10x for that. Let's tidy this up now. We can put the 7 with the 10 at the front, so we get 70 with the x times the bracket, all to the power 6, and that's worth 2 marks. P and Q have these coordinates in 3 dimensions respectively. Find the coordinates of the point R, which divides PQ in the ratio 2 to 3. So just draw a line P to Q and put R somewhere between it. And we know that the ratio is 2 to 3, so the first part is going to be 2 and the second part is going to be 3. Of course, the whole line PQ has a total length here of 5. So we can say that the vector PR is 2/5 of the vector PQ from this diagram. Now we know what PR is in terms of position vector. It's R minus P, and PQ is Q minus P, so we can state this. I want to isolate R, so let's take this negative P over this side. There's what we get, it just becomes plus P. Now we put the vectors in. The position vectors come from the coordinates. So we just go 2/5 of, that's a position vector Q, take away P, and then we add P at the end. But this these two things have got to be multiplied by 2/5 once you make them one vector here. So what do we get? We get 5, 10, minus 10. Why is that? Because -1 minus minus becomes plus, so it's 6 minus 1 is 5, 11 take away 1 is 10, and -8 take away 2 is -10. The next step is to multiply this by 2/5. 2/5 of 5, 2/5 of 10, and 2/5 of -10 gives you 2, 4, and -4. And then to finish this off, you just add the two vectors there. And we get 2 and -6 is -4, 4 and 1 is 5, and -4 plus 2 is -2. That's position vector R. So R is going to be the point -4, 5, -2. That's worth 2 marks. Question 5. We have a function h defined by h of x is 2x cubed take away 7. We want to find the inverse function h to the minus 1 of x. So we just change this into y. So h of x is y, and then we say 2x cubed minus 7. All we do now is we just swap sides. We say 2x cubed minus 7 must be the same as y then. We want to try to isolate x on its own on this side, so we will add 7 to both sides. Add 7 to both sides gives you y plus 7. We don't want the 2 here, we just want x cubed, so divide everything by 2 now, y plus 7 over 2. We don't want x cubed, we want x, so we take the cube root of both sides, and that gives you the answer for x. The next step is we change this x into y and this y into x. Now this y here is related to the inverse function. This one here is actually h of x, but this y here is h to the minus 1x. So we finish off by saying h to the minus 1x is the cube root of x plus 7 all over 2. 3 marks for that question. Question 6. We have a right angled triangle and the sine of p is 1 over root 5 and p lies between 0 and pi by 4 radians. We want to determine the value of sine 2p. Well, the first thing we've got to do is find this missing side. We just use Pythagoras, so square that, take them away and take the square root. When you square a square root you get 5. When you square 1 you get 1. 5 take 1 is 4 and the square root of 4 is 2. So we have all the sides so we can find sine, cosine and tan if we need them. So what do we want? We want sine of 2p. So we've got to remember that from the trig formula sheet, sine of 2a is 2 sine a cosine a. So let's use that there with p instead of a, 2 sine p cosine p. Now we got the value for sine p in the question, so we can change that sine p into 1 over root 5. Cosine p is going to be adjacent over hypotenuse, 2 over root 5. So here we've got as 2 times 1 over root 5 times 2 over root 5. Let's multiply the tops. 2 by 1 by 2 is 4. Root 5 times itself is 5. So the final answer for that is 4 over 5. And that's, well, actually that's 1 mark. Next part, the cosine of 2p. Now there's three formulas you can use. Now because we were given this one, I'm going to use this one. 1 take away 2 sine squared a. But you could use that. You get the same answer. Let's do it the way that I said it. So I'm going to say 1 minus 2 sine squared p, which is equal to 1 take away 2 times 1 over root 5 squared, because sine p is 1 over root 5. If you square that, you've got to put it in brackets and then put squared here. So let's just finish this off. We get 1 take away, well, when you square 1, you get 1. When you square a square root, you just get the number 5. And then you multiply this by 2, so you're going to get 3 over 5. So that's 1 take away 2/5 is 5/5 take away 2/5, which is 3/5. Then it says, hence determine the value of sine 4p. So I'm going to use this formula. Sine 4p will be 2 times sine 2p times cosine p. It's the same formula here. And all we need to do now is we put these two values in to this formula here. And what do we get? We get 2 times 4 over 5 times 3 over 5. What do we get here then? 8 times 3 is 24 over 25, and that's the final answer. And that's the end of the question number 6. Right. Question 7. The line y equals 2x is a tangent to the circle with equation this. determine the coordinates of the point of contact. Now, if it's a tangent, it can only touch a circle at one point. So we know that when we solve this line here and this circle line here simultaneously, we're going to get one solution. So let's look at this, a straight line and a circle. We now put y equals 2x into this equation. Every time we see y, we replace it by y equals 2x, the substitution method. So this we'll get x squared plus bracket 2x all squared, take away 14x, take away 8 times 2x plus 45. That's just replacing y by 2x here and here. Now we square out the bracket and multiply this bracket here by minus 8 to get x squared plus 4x squared, take away 14x, take away 16x plus 45 equals 0. We tidy this up now, so we get x squared plus 4x squared is 5x squared, and negative 14 take away 16 is negative 30x, and then plus 45. We have a common factor of 5, let's take that out. So we get 5 bracket x squared minus 6x plus 9 bracket equals 0. Now we know that this is only going to have one solution or one factor, so it's going to be x minus 3 all squared, and then we can find what x is from this. X must equal 3. And that's consistent with the fact that it's a tangent. Now we put this back into this equation, y equals 2x, so we know that x is 3, so then y equals 2 times 3, 6, and then we just finish it off by saying the point of contact is the point 3, 6. Question 8. We have a quadratic equation here and it has no real roots. Determine the range of values for m. Justify your answer. So we know this is a quadratic equation, so we can write down the coefficients. A equals 1, B equals m take away 4, and C equals 2m take away 3. No real roots implies that b squared take away 4ac is less than 0. So we plug these values in to this left hand side here, and we get bracket m take away 4 all squared take away 4 times 1 times 2m take away 3 is less than 0. We square out the bracket and multiply through by minus 4 here, and we get m squared take away 8m plus 16 for the first part, and then negative 4 times 2m is negative 8m, negative 4 times negative 3 is positive 12. We tidy this up now and say m squared take away 16m plus 28 is less than 0. Now we want to factorise this as if we can. We want two numbers that multiply to give positive 28 and add together to give negative 16. And there they are, negative 2 and negative 14. Now this is a positive m squared, so we can then draw a graph that looks like this. We draw on the x-axis. In this case it's the m-axis because the values are m. We've got m equal to 2 and m equal to 14 as the roots. So there's your two roots, and 2 and 14 are the roots. Now above this m line and below this m line we have positive and negative values. In the green part we've got the y coordinate is bigger than 0, and then below this line we've got y is less than 0. Now we want it to be less than 0, so we want this curve to be in the yellow part of my diagram here. So that means that the range for m will be m is greater than 2 but less than 14. And that's 4 marks for that question. Express log base a 5 plus log base a 80 take away 2 log base a 10 in the form log base a of k, where k is a positive integer. Okay, the first thing we've got to do is change this third term. So it becomes the first term doesn't change, the second term doesn't change, but we bring the 2 inside the log part and it becomes a power, so it's 10 squared. Next step is to just work out what 10 squared is, which is 100. Now when we add 2 logs, we can find a single log by multiplying the 5 and the 80 together, but we're taking away a log, so then we can divide by 100. So we're going to have a single log that says log base A, 5 times 80 all over 100. 5 times 80 is 400, divided by 100 is 4, so the final answer is going to be log base A of 4, and that's 3 marks. Next question. Show that x minus 1 is a factor of this polynomial. And it says for part B, hence or otherwise factorise it fully. So we do it by synthetic division, and there it is. When you have x minus 1 here, you put a 1 there, and then these numbers up the top come from the coefficients of each of these terms here. So 2, 3, negative 4, negative 3, 2 are these numbers that you see here. So we bring this down, multiply it by 1, we get 2. We add these two numbers, that's 5, multiply by 1 to get 5. We add these two numbers to get 1. We multiply by 1 to get 1. We add these two numbers to get negative 2. Multiply by 1 to get negative 2. We add these and we get 0. Now this is the remainder, and we've got a remainder 0, so we can say the remainder is 0, so x minus 1 is a factor. So what can we say? We can say the original polynomial can be equal to x minus 1 times this cubic expression. Where do we get these from? We get them from this part here. So that'll be x cubed coefficient, x squared, x to the power 1 and x to the power 0, or a constant. Now, we want to try to factorise this, so let's just try this again by synthetic division. You try factors of minus 2. We've already got 1, so let's try negative 1. So we're going to put x minus 1 here, and it does give you a remainder 0, so let's just check this out. Bring the 2 down, multiply by negative 1 is minus 2 or negative 2. 5 take away 2 is 3. Multiply by negative 1 gives you negative 3. Add gives you negative 2. Multiply these together and it gives you 2. And 2 and negative 2 gives you 0. So we can then say we have x plus 1 as a factor. That's this one here. We had this one already, and we have a quadratic equation here. Now this does factorise, and we get 2x minus 1, x plus 2. It's not too difficult to work out that one. You can do it by trial and error, or you can do it by another method, but that's the final factorisation, and the whole question is worth 6 marks. The next question. Express cosine x plus root 3 sine x in the form k cos bracket x minus alpha, where k is bigger than 0 and a lies between 0 and 360. So let's do that first. And so the first thing to do is expand out this cosine x minus a and then multiply everything by k. So we get cosine x cosine a multiplied by k plus sine x sine a multiplied by k. Now we need to compare it with what we had, so let's just put that above it. So we're going to compare this line with the line underneath it. Cosine x there, so we've got k cosine a must be 1. And then here we've got sine x here, sine x there, so k sine a must be root 3. Okay, so that's what we write down. We say k sine a, I'll put the sine a first for a reason, and that's this one here. K sine a is root 3, and then k cosine a is 1 because we've only got 1 times cosine x. So to find k, we just find the square root of this squared plus that squared. So 1 squared is 1, root 3 squared is 3, 3 and 1 is 4, so the answer is going to be root 4, which is 2. So k equals 2, and that's a positive number. Now we want to find the angle, so the reason I wrote it like this is because you can now put k sine a over k cos a to get tan a. So tan a will be root 3 over 1, which is root 3. Now we want to know which quadrant will a lie in, and we see that sine a is positive here, and it's positive there, and then cosine a is a positive here and here. So the answer must be that a lies in quadrant 1. So let's find this out. So we got a is the inverse tan of root 3. So we've got to draw the special triangle, and we should know this one. 60 degrees there, 2 there, 1 there, root 3. So tan will be root 3 over 1. That's what we have. Inverse tan of root 3. So we want root 3 over 1. That's the tan. So it's tan of 60. So the angle will be 60 degrees. So A equals 60 degrees. So we can say that this original expression on up here can be written in the form 2 cosine x take away 60. It says, hence or otherwise sketch the graph and use the diagram provided in the answer booklet. Well, I don't have an answer booklet here, but this is what we do. We say, there's a cosine graph. We have got 2 times the cosine, so we're going to have a graph that goes up to not 1 but 2, and not down to -1 but -2, and it's going to be shifted by 60 degrees to the right. So it's going to look something like this. So you can see we have a maximum value of 2, a minimum value of -2, and instead of starting at 0, beg your pardon, instead of having a maximum here at 0, you go to 60 degrees and have a maximum there, and then a minimum over here at this number. So you're going to have 2 points, maximum point, minimum point. You should indicate these. It's going to be 60 degrees and 2, and the minimum point is going to be at 240 degrees and -2. And that's for 4 marks altogether. Question 12. The function f is given by f of x equals 12 times the cube root of x. When x is a, the rate of change of f with respect to x is 1, determine the value of a. So the first thing we've got to know is the rate of change of any function with respect to x is given by its derivative, in this case f dashed of x. So we've got to differentiate f of x. Before we do that, we've got to change this into a form that's differentiable. So we change the root form into a power form. So cube root becomes x to the power 1/3. So differentiating, we bring the third to the front, the 12 stays in the middle, and the x becomes x to the power 1/3 take away 1, which is x to the power -2/3. Next step is to multiply a third by by 12 to get 4 on the top, and also at the same time we'll bring this negative power down to make it a positive power, and then we'll change it back into the root form. So we say f of x equals 4 over the cube root of x all squared. Now, when x is a, we know that f dashed of a equals 1, so we're just going to do this. We're going to say f dashed of a will become 4 over the cube root of a all squared equals 1. We've got a fraction that equals 1, numerator is 4, so the denominator must also be 4. So we can say that the cube root of a all squared equals 4. We don't want a square term, we just want a single thing, so we take the square root of both sides. So we get the cube root of a equals 2, and then to get a, we do the opposite of cube root, which is the cube. We cube both sides, so we get a equals 2 to the power 3, which is 8. We come to the last question, and it's a circle question. P and Q are points on a circumference, 4, 10 here and 6, 2 there. We want to, in part A, find the equation of the perpendicular bisector of PQ. Now that's the line given there. Let's call it AB. Now if it's a bisector, this point here is the midpoint. Now we can find it by using the 2 endpoints and finding the averages of the x coordinates and the y coordinates like this. So we just add up the x coordinates and divide by 2. We add up the y coordinates, divide by 2, and you get 5, 6 as this point here. Now the next step is to find the gradient of PQ. Now that's going to be the difference in y's, that's 10 take away 2 on the top, over the difference in the x's, that's 4 take away 6. When you work this out, it's not too difficult to do. It's going to be 8 over -2, which is -4. The next step is we've got to find the gradient of AB. So we know that the gradient of AB has to be a quarter. Why is that? The two gradients of perpendicular lines must multiply to give -1. So we've got -4 here, times a quarter gives you -1. So this gradient is a quarter. So to find the equation of this perpendicular bisector, we say y minus b equals mx minus a. This is the m that we use. We'll stick it in there, and a and b are these two numbers up here. So let's just stick them in. We get y take away 6 is a quarter, x take away 5. Let's multiply everything by 4. So we get 4y take away 64 equals x take away 5. And let's just tidy up any way you want. I'm going to do it so that everything's on a positive side with 0 on the right hand side. So we're going to have x take away 4y. How do I get 19? Well, this take away 24 becomes a plus 24. 24 take away 5 is 19, and that's part A. That's worth 4 marks. Now, we want to find the equation of this circle. I'll do it on the next part. Now, to get the equation of that circle, we know that this is a diameter, because when you go to a chord and you draw a line perpendicular from the middle of it, it has to pass through the centre. So this is a diameter. Now this is another chord, so we can also do the same. Then the centre will be where these two lines meet. So we have this point is the centre of the circle. Now, we know that this will be x equals 9. This is the line x equals 9 because it says the chord is horizontal. If this chord is horizontal, then this line, this red line here, is vertical. And we know it's 9 because it's going to be halfway between x equals 6 and x equals 12. 12 and 6 is 18. Half that, 9. So there's x equals 9. Now we have two equations now. We've got x equals 9, that's this one. Now we did in part A, we found the equation of AB. And all we need to do is we just put x equal to 9 into this equation to find y. So we say 9 take away 4y plus 19 is 0. We tidy this up to say 4y then, by moving over to the side, will be equal to 28. Divide now by 4 to get y. So y equals 7. Let's take it back. And we know that, oh, beg your pardon, we know that x is 9, so we're going to say that the centre of the circle is 9, 7. Now we need to find the radius. Now that you could go from here to here, you could go from here to here, but I'm going to go from here to here, so let's just do that. And there's the radius. To find this, we just need to find the radius squared, because that's what we use in the equation of a circle. So I'm going to say radius squared will be 12 minus 9 squared, because I'm using this x coordinate and this x coordinate, so it's going to be 12 take away 9 squared, that's the first one, and then 2 take away 7 squared, that's the second one. When you do that, you get 3. When you do that, you get negative 5, but you're going to square them both, so you're going to get 9 plus 25, so you got a radius equal to 34. So the final part of this is to find the equation of a circle. It's going to be x minus 9 all squared plus y minus 7 all squared equals 34, and that's using the centre here and the radius squared there. And that's the end of the question paper. That was worth 4 marks.